Every time you ask ChatGPT a question, it uses 10 times more electricity than a Google search. That's one query. Now multiply that by hundreds of millions of users every day. AI is pushing data centers to the breaking point. And if you work in IT, this is going to affect your world whether you manage infrastructure or not. AI workloads are fundamentally different from anything data centers were designed for. Traditional servers, the kind running your email, your databases, your web apps, they draw maybe 5 to 10 kilowatts per rack. An AI-optimized rack full of GPUs, that's 40 to 100 kilowatts. Same physical footprint, 10 times the power. And more power means more heat. You can't just blow cold air at it anymore. The industry is moving to liquid cooling and immersion cooling, systems that literally run coolant through the servers. Lulu Shiraz from Vertiv described it well. The data center is becoming a highly integrated system where chips, servers, and infrastructure have to work in lockstep. It's not just about buying more servers. The entire facility needs to be redesigned around AI workloads. And the power grid? It's not ready. In Virginia in 2024, a single lightning strike caused 60 data centers to switch to backup power at the same time, dropping 1,500 megawatts off the grid in one go. That nearly caused a blackout for millions of people. In Ohio, the utility company had to stop approving new data center connections entirely because demand was growing faster than the grid could handle. They went from 100 megawatts of data center load to 600 megawatts in 4 years. So why should you care if you're not running a hyperscale data center? Cloud costs are going up. If you're using AWS, Azure, or GCP, the cost of running AI workloads is directly tied to the energy costs underneath. As power gets more expensive and scarce, cloud pricing follows. If your organization is adopting AI tools, your cloud bill is going up. Availability is becoming a real constraint. Some regions are running out of capacity. If your business depends on spinning up new infrastructure in certain locations, there may be a waiting list. This is already happening in Northern Virginia, the largest data center market in the world. Sustainability reporting. More organizations are being asked about the carbon footprint of their IT operations. If you're running AI workloads in the cloud, that energy consumption shows up in your Scope 3 emissions. Your CFO or sustainability team is going to start asking questions. Your electricity bill. According to Carnegie Mellon Research, US electricity bills could rise 8% nationally by 2030, and up to 25% in high-demand areas like Virginia. This isn't just a data center problem, it's an everyone problem. Now here's an angle that doesn't get enough attention. Ben Henshaw makes the point that everyone talks about hardware solutions, better cooling, more renewable energy, nuclear power deals. Microsoft literally spent $1.6 billion to restart the 3 Mile Island nuclear plant to power their AI infrastructure. But software efficiency is massively overlooked. Henshaw compared it to cars. Fuel economy didn't just come from bigger fuel tanks. It came from smarter engine management. The same applies to data centers. Efficient infrastructure software, better container orchestration, workload scheduling, resource allocation can meaningfully reduce how much energy your AI workloads actually consume. This is something we see at Darematic. Before you scale up your AI infrastructure, the question worth asking is, have you optimized what you're already running? In a lot of cases, the first step isn't more hardware, it's smarter software. And this isn't concentrated in one country. In Australia alone, Microsoft and Amazon have committed $25 billion to new data centers. Data center power demand there is growing 25% a year. By 2035, data centers could consume up to 11% of the national grid, up from 1% today. In Europe, the industry has pledged to go carbon neutral by 2030, with formal EU regulations on the way. This is a global infrastructure shift, and it's happening fast. So here's what I take away from this if you're working in IT. 1. Budget for rising costs. If your organization is adopting AI tools or running AI workloads in the cloud, factor in rising energy costs. Cloud pricing is not going down. Build that into your forecasts. 2. Optimize before you scale. Before you add more GPU instances or bigger clusters, look at your software stack. Are your workloads efficiently scheduled? Are you right-sizing your infrastructure? Software efficiency is the cheapest efficiency gain available and the most overlooked. 3. Watch the regional picture. If you're making decisions about where to host infrastructure, energy availability is now a factor. Some regions are going to have capacity constraints. Some already do. Plan accordingly. 4. Get ahead of the sustainability conversation. Your organization will be asked about AI's energy footprint. Have an answer ready. Know what your cloud provider's energy mix looks like. Know what your options are. The AI revolution is real, but it runs on electricity. And electricity is the one thing that doesn't scale with a software update. If you want practical IT news like this, subscribe. We're dramatic, and we cover tech through the lens of people who actually work in IT. See you next week.